All right, so here, make sure you read very carefully. I know that I have a particle moving along the x-axis, so I have velocity here in the graph. I don't have a function for it, but this is the graph of the velocity, and I've been told it's differentiable. And they're saying, I'm not trying to trick you, the velocity really is 0 at time 0 and 3 and 5. And it tells us about horizontal tangents, so it turns out we don't actually need that, at least not for now. Here, I've been told the areas of the regions bounded by the t-axis in the graph. Between time 0 and 3, this area is 8. Oops. Between time 3 and 5, that area is 3. And between time 5 and 6, this area is 2. That's going to help me later. And I know that x of 5 is -2. All right, so let's see if I can answer these questions. Can you write an integral expression that gives total distance traveled? I hope so. Please make sure you know these two definitions. So to find total distance traveled, I need to integrate, in this case from time 0 to 6, the absolute value of the velocity. And can I now find that total distance? Just for completeness, I might write the integral from 0 to 6 of the absolute value of v of t dt. And remember what that means. It means I'm going to pretend that all the areas between the t-axis and the velocity curve are positive. Now I know they're not in this case, but I want that 8 steps that got taken backward to count as 8 steps. So this is going to be 8 plus 3 plus 2, which makes 11, 12, 13. So number 7, can I write an integral expression for displacement? Well, displacement over the interval times 0 to 6 is going to be the integral from 0 to 6 of the velocity. No extra bells and whistles. Displacement is the integral of velocity. Now, when I'm asked about the displacement, I'm going to have to take into consideration the signs of those areas in the graph. In this case, that 8 is like a -8 plus a +3 and a -2. So that's -10 plus 3. My displacement is -7. Notice any question about total distance traveled, any question about displacement have nothing to do with where you were when you started. They're all about how much change happens in the given time interval. All right, for question 8, this is an optimization question. Notice this word, furthest. That's a superlative. So I need to figure out when the particle is furthest to the left. That means I'm going to need an expression, a function that gives me the position. Well, I don't really know a formula for v of t, but that doesn't mean I can't write an integral function that describes the position. So x of t is going to be some starting position plus the integral from some time that I don't know yet to t of the velocity function. I have to scroll up to the top to remember what that ordered pair was. At time t equals 5, the particle is at position x equals -2. This is going to be -2 plus the integral from 5 to t v of p dp. All right, and I'm going to need a table of values. That table is going to have to include the endpoints, which are 0 and 6. I'm trying to maximize, well, in this case, furthest left means minimize position. So I'm going to need to figure out the position at those endpoints. And I'm also going to need any critical points. So that's places where the derivative of position is 0. Derivative position is velocity. So I need to know when is velocity equal to 0. So you might ask yourself, we might say, like, I know that if I want a minimum, the only possible locations are the endpoints and locations of relative minimums. So you could tell yourself, here's the velocity. It's 0 twice. at time 3 and time 5. But I only really need maybe to consider the time when velocity changes from negative to positive. So if at this point you put the number 3 in your list, or if at this point you put both the numbers 3 and 5 in your list of possible times when the minimum could occur, those are both good strategies. You would not lose points whether you included or didn't include 5, but you must include 3. I'm going to include 3. If you include 5, you're going to end up doing a little bit of extra work, but nobody would hold it against you. So are there any of these times that I actually know the position? No, because the one time that I was told about the position is time 5, and that's not one of my candidates. So I'm going to have to figure out the position at time 0, the position at time 3, and the position at time 6. I'm going to change to a different whiteboard. All right, well, the order I fill in my table doesn't really matter. Watch, it's a little bit maybe less stressful if I start with times 6. So my x of 6 is going to be negative 2 plus the integral from 5 to 6 of v of p or v of t. At this point, it doesn't matter. And I already know that the area under the velocity curve between 5 and 6 is negative 2. So that was 2, but it's underneath the t-axis. It's going to be negative 2 plus negative 2, which is negative 4. Now I'm going to have to figure out x of, for example, 3. That's going to be negative 2 plus the integral from 5 to 3 of v of t dt is negative 2 minus the integral from 3 to 5 v of t. Well, I have to get that picture up and say that between 3 and 5, did I know the area? And the answer is yes. Between time 3 and 5, the area between the t and the v, between the t-axis and the v curve, was a positive 3. So it's going to end up being negative 2 minus 3, which is negative 5. That was for time 3. Now I'm going to have to, just to clarify, this is the x of t function, the position function. I'm plugging those candidate times into the x of t function and figuring out the position at those times. Now I'm going to need to figure out to x of 0. X of 0 is going to equal negative 2 plus the integral from 5 to 0 v of t dt, which is negative 2 minus the integral from 0 to 5 v of t dt, which is negative 2 minus, and then between 0 and 5, I know my area is supposed to be a negative 8 and a positive 3. This is going to end up being negative 2 minus negative 5. It's like negative 2 plus 5, which is a positive 3. So the question, when is the particle furthest to the left? I'm going to pick the smallest x value. That's 5 spaces left of whatever, the origin in this case. And I'm going to write up my answer here. So here's what I wrote up. I was asked to justify my answer. The thing I have to justify is why did I only have to test those 3 t values? So I say candidates for the time at which the particle is furthest left are t equals 0 and 6, the endpoints of the time interval, and t equals 3, where x prime of t, which is v of t, changes from negative to positive. And then after that, I just look at my list of outputs of my x values, my position values, and I pick the smallest one. So I say this particle is furthest left at time t equals 3, when the particle's position is x of 3 equals negative 5. Final answer.